Good morning. Welcome to algebra class. From this week, we are now on chapter 7, lesson 5, solving square roots and other radical equations. Before we start, I want you to prepare the following: your algebra book, your pen, and your... Before we start, let's define what is a radical equation. Radical equation is an equation that has a variable in the radical. Let us solve number 1. Example, square root of x plus 5 equals to 14. We need to isolate square root of x on the other side. So we need to transfer positive 5 on the other side of the equation. Or the inverse of positive 5 is negative 5. So 14 minus 5 is equal to 9. We have a square root of x equals 9. How to cancel square root? We need to square or put square on both sides of the equation. So x is equal to 9 squared, or x is equal to 81. To check your answer, let's plug in the value of x to the original equation. Square root of x, or square root of 81 plus 5 is equal to 14. What is square root of 81? That is 9. And 9 plus 5 is equal to 14. So it means our answer x equals 81 is correct. Next, we have example 2, square root of c minus 2 equals 6. How to remove the radical sign? To remove the radical sign, we need to put square on both sides of the equation. So c minus 2 is equal to, what is 6 times 6? 36. So c minus 2 is equal to 36. Now to get the value of c, isolate variable c on the other side of the equation and transfer negative 2 to the other side. So we have c is equal to 36 plus 2 is 38. To check your answer, we need to plug in the value of c to the original equation. We have square root of c minus 2, or square root of 38 minus 2 is equal to 6. 38 minus 2 is 36. What is square root of 36? Yes, that is 6. So 6 is equal to 6. So it means our value of c is correct. Before we proceed to our discussion, let us watch this video.
Take this equation and solve it for x. In this equation, we have our variable x right here, but it's underneath this radical. If you have a problem where your variable is underneath the radical, in order to solve, you first need to take your problem and isolate the radical on one side of the equal sign. That way you can then square it to remove the square root. So in this problem, since x is underneath the square root, we first need to solve for this square root. So to do that, we use the order of operations, but in reverse. That means we need to start by adding 8 to both sides, in order to move 8 to the other side of our equation. When we do, we have 6 times the square root of 2 times x is equal to 12 plus 8, which is 20. Now to get that radical fully by itself, we need to divide both sides by 6. When we do, these 6's cancel out, and we're left with the square root of 2x on one side. On the other side, we have 20 over 6. Well, both of those numbers are divisible by 2. So we can divide both the numerator and denominator by 2 in order to reduce that fraction to 10 over 3. Great! Now we have the radical by itself on one side of the equal sign. So in our next step, we want to take that radical and get rid of it. In order to do that, we need to perform the opposite operation. So instead of taking the square root, we need to square. So in step number 2, we want to square both the left and the right-hand sides of our equation. When we do, the square root and square cancel each other out, since they're opposite operations. And we're left with 2x on the left. On the right, we take 10 and square it and get 100. And we take 3 and square it and get 9. So we get that 2x is equal to 100 over 9. Hey, we removed the square root from over x. That means we can now take this equation and solve it for x. So in step number 3, we need to divide both sides by 2 in order to get x by itself. But look at this right-hand side. We have a fraction. So instead of dividing by 2, let's multiply both sides by 1/2. Since dividing by 2 and multiplying by 1/2 are the same things. Now when we do, this 1/2 times 2 becomes 1. So we just get x on the left. On the right, we can simplify. Here, 2 goes into 100 50 times. So 2 becomes 1 and 100 becomes 50. So we have 50 times 1 in the numerator, which is 50, and 9 times 1 in the denominator, which is 9. So we get that x is equal to 50 over 9. But before we call this our answer, look at what we started with. In our original equation, our variable x was underneath a radical. If you have a problem like this where your variable is underneath a radical, you have the possibility of getting an answer that is not a solution to your original equation. That means that step number 4, checking your answer, is a must to make sure that this is an actual solution to your equation. To check your answer, take the value you got for x and plug it into your original equation to see if you get a true statement. So here we have 6 times the square root of 2 times x. X we got to be 50 over 9. Then we subtract 8, and we want to know if that equals 12. So here we simplify using the order of operations. First we multiply inside the square root. If we take 2 times 50 over 9, we get 100 over 9. Continuing to simplify, we take the square root of 100 over 9. To do that, we can take the square root of 100, which is 10, over the square root of 9, which is 3. So let's see. We then take 6 times 10 over 3. Well, 6 times 10 is 60, then divided by 3 is 20. So we have 20 minus 8. Is that equal to 12? Yes, it is. 20 minus 8 equals 12. So we get that 12 equals 12. A true statement. Since we got a true statement, we know that this is our answer. In this problem, x is equal to 50 over 9.
On problem number 1, solving a square root equation. What is the solution of 3 plus square root of 2x minus 3 is equal to 8? First, we need to isolate the radical expression. We have 3 plus square root of 2x minus 3 equals 8. Transfer 3 to the other side of the equation. So it will be 8 minus 3, and that is 5. Square root of 2x minus 3 is equal to 5. Now, how to get rid of the radical sign? We need to put square on both sides of the equation. Next, simplify. 2x minus 3 is equal to 5 raised to 2. So what is 5 raised to 2? Yes, and that is 25. Now, transfer negative 3 to the other side. It will become 25 plus 3. And 25 plus 3 is 28. What is 2x is equal to 28? Divide both sides by 2. It will be x equals 14. Problem 1, got it? Let us solve this question. What is the solution of square root of 4x plus 1 minus 5 equals 0? I'll give you 10 seconds to answer this question. Timer starts now.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Time's up. Let us check your answer. The answer is x equals 6. From the solution of square root of 4x plus 1 minus 5 equals 0, we need to transfer negative 5 to the other side of the equation. So we have square root of 4x plus 1 is equal to 5. Now, how to remove the radical sign? Yes, we need to put square on both sides of the equation. Now, we have 4x plus 1 is equal to 5 squared. What is 5 squared? Yes, and that is 25. 4x plus 1 is equal to 25. Now, we need to make variable alone. So we need to transfer positive 1 on the other side of the equation. So 4x is equal to 25 minus 1 is, very good, that is 24. Now we have 4x equals 24. Simplify, divide both sides by 4. 24 divided by 4 is x equals 6. Very good. Number 2. Solving other radical equations, Part A. What is the solution of 3 times x plus 1 raised to 2 over 3 is equals to 12? What we know, the equation and the power of the exponential expression. What we need, solution of the equation. And what is our plan? To isolate the exponential expression and to use the inverse of the power to simplify and solve the equation. Since our given is 3 times x plus 1 raised to 2 over 3 is equals 12, first step, we need to divide each side by 3. X plus 1 raised to 2 over 3 is equals to 4. Why? Because 12 divided by 3 is 4. Next step, reach each side to the 3 over 2 power. Think, how can you get rid of the rational exponent? We need to raise each side to the reciprocal power. Since our rational exponent is 2 over 3, we need to put the reciprocal both sides of the equation. So that's why we put 3 over 2, both sides. Now, simplify. Since the numerator of 2 over 3 is 7, which is 2, we need to put the absolute value of x. So x plus 1 raised to 6 over 6 is equal to 4 raised to 3 over 2. Now, what is 4 raised to 3 over 2? Since our denominator is 2, it means this is square root. So what is the square root of 4 raised to 3? Yes, and that is 8. So the absolute value of x plus 1 is equal to 8. Now, x plus 1 is equal to positive and negative 8. To get the absolute value of x plus 1, we need to put positive negative to the other side of the equation. Now, what is x plus 1 is equal to positive 8? Yes, and that is x is equal to 7. How about x plus 1 is equal to negative 8? Simplify. It will be x equals negative 9. So what are the solutions? The solutions are 7 and negative 9. Part B. What is the solution of 3, the fifth root of x plus 1 raised to 3 plus 1 is equal to 25? The first step is, we need to rewrite the radical using a rational exponent. So we have 3 times, since we have the fifth root of x plus 1 raised to 3, we can rewrite this as 3 over 5. So 3 times x plus 1 raised to 3 over 5 plus 1 is equal to 25. Now, to simplify, since we have 3, we can divide both sides of the equation. So we have 24 divided by 3 is 8. So x plus 1 raised to 3 over 5 is equal to 8. Now, think, why is isolating the variable important? If you raise each side of 3 times the fifth root of x plus 1 raised to 3 plus 1 is equal to 25 to the power of 5 over 3, you will end up with a more complicated equation, not a simpler one. Next step, raise each side to the 5 over 3 power. Since we have rational exponent 3 over 5, get the reciprocal of it. That's why we have 5 over 3 on both sides of the equation. So x plus 1 raised to 3 over 5 times 5 over 3 is equal to 8 raised to 5 over 3. Now, we can simplify x plus 1 is equal to, what is 8 raised to 5 over 3? Since our denominator is 3, it means this is cube root. Now, what is the cube root of 8 raised to 5? Yes, and that is 32. That's why we have x plus 1 is equal to 32. Then subtract 1 from each side. So what's the value of x? X is equal to 31. Solving radical equations with rational exponents. Another example, we have 2 times x minus 2 raised to 2 over 3 is equal to 50. Are the parentheses by itself on the left side? No. Divide by 2. So that's why we have x minus 2 raised to 2 over 3 is equal to 25. Because 50 divided by 2 is 25. Next, x minus 2 raised to 2 over 3 raised to 3 over 2 is equal to 25 raised to 3 over 2. Since from our original equation, it has the rational exponent 2 over 3, we will get the reciprocal of it. So the reciprocal of 2 over 3 is 3 over 2. And let us put 3 over 2 on both sides of the equation. Is the numerator of the original fractional exponent even? Yes, it's even. So you are taking the second, fourth, sixth, so on and so forth root of this problem. So we need to put the absolute value around the next variable expression. So there could be a positive and negative answer for x. So remember, if we have absolute value, we need to put positive, negative on the other side of the equation. So x minus 2 is equal to the square root of 25 raised to 3. So we will put the absolute value of x minus 2. So x minus 2 is equal to, what is the square root of 25 raised to 3? Yes, and that will be 125. So x minus 2 is equal to 125, or x minus 2 is equal to negative 125. So if we simplify this, for x minus 2 equals 125, it will be x equals 127. And the other is x equals negative 123. Example number 2. Check for extraneous solutions. Are the parentheses by itself on the left side? No, so we need to divide by 2. So x plus 3 raised to 3 over 2, that is equal to 27. Oh, then again, we have 3 over 2 in our exponent. So get the reciprocal of it. So we have 2 over 3 on both sides of the equation. So x plus 3 raised to 3 over 2 raised to 2 over 3 is equal to 27 raised to 2 over 3. Is the numerator of the original fractional exponent an even? No. So you are taking the third, fifth, seventh, so on and so forth, the root of this problem. So you don't need the absolute value around the next variable expression. So since our numerator is an odd number, we will not put positive, negative on the other side of the equation. So x plus 3 is equal to cube root of 27 raised to 2. Then simplify. What is cube root of 27 raised to 2? Very good. And that is 9. So what is x plus 3 is equal to 9? That is x equals 6 because 9 minus 3 is 6. Next, we have 3 times x plus 1 raised to 3 over 5 is equal to 24. Are the parentheses by itself on the left side? No. So we need to divide by 3. That's why we have x plus 1 raised to 3 over 5 is equal to 8. Now, since we have the rational exponent 3 over 5, we need to get the reciprocal of it, which is 5 over 3. Put 5 over 3 on both sides of the equation. Okay, look at the numerator. The numerator of the rational exponent is 3. It's an odd number, so we don't need the absolute value around the next variable expression. So x plus 1 is equal to the cube root of 8 raised to 5. To simplify, x plus 1 is equal to 32. It will be x equals 31. Problem number 2. Got it. What are the solution or solutions of 2 times x plus 3 raised to 2 over 3 equals 8? I'll give 10 seconds to answer this question. Timer starts now.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Time's up. Let's just check your answer. The answer is x equals 5 or x equals negative 11. From the equation, we have 2 times x plus 3 raised to 2 over 3 equals 8. Simplify. Since we have 2, we need to divide it by 2. 8 divided by 2 is 4. X plus 3 raised to 2 over 3 is equals to 4. Now, since we have rational exponent 2 over 3, get the reciprocal of it. And that is 3 over 2. So put 3 over 2 on both sides of the equation. Now we have x plus 3 raised to 6 over 6 or 1 is equal to 4 raised to 3 over 2. Look at the rational exponent. Our rational exponent has even number. So if we have even number 2, we will put absolute value and we need to put positive negative on the other side of the equation. So we have x plus 3 is equal to positive negative 8. Then simplify. For x plus 3 equals positive 8, that is x equals 5. And for x plus 3 is equals to negative 8, it will be x equals negative 11.